Hello everyone, welcome back to another board repair. Today we received a motherboard for which is an HP motherboard, so it doesn't turn on. So let us diagnose this motherboard and see whether we can repair this motherboard and try to turn on this motherboard. Okay. So I'll just connect the DC power supply and the ampere is taking around, so you can see the ampere took around 33 milliamp and it's back to zero. There is no current drawing right now, so we can confirm that there's a problem on the main power rail or else the standby section in this motherboard. So the standby section is on this side, so here we have 3 volt and 5 volt output. So we are all familiar with this type of motherboard, so we say this as a gun type motherboard. It looks like a gun, so we are always familiar with this motherboard. So here we have a standby section, so RAM section and the CPU section. So every cords are on the back side. So still there is no current reading, so it's 0. Let me reconnect it again. Yes, there's no reading. No light on the charger as well, on the DC jack. So if there's no light on the DC jack, the EC chip has not functioned. So for the EC chip to function or it to work, we need 3.3 volt LDO from the standby IC to the EC chip. So let me check one by one. So from the main power rail, then we can go one by one back to the standby IC and into a motherboard. Okay, I'll just connect the adapter again. Now you see the ampere is taking around 33 milliamps, then back to 0. So something is happening in this motherboard. So it is trying to do something, then it is back to 0. So here we have the first MOSFET, I think. So let us check the voltage on the input side. So 19 volt, okay. 19 volt, this is most probably, yeah, this is N channel MOSFET. So on this side we have the drain and on this side we have the source. So normally the N channel MOSFET diode direction is from source to drain. So the diode direction is like this way, from source to drain. So that's why we are having 25 volt as a drive voltage for the N channel MOSFET. So we need to find the second MOSFET. Most probably this is the first MOSFET, I think. So we have a small MOSFET on this side here. You can see this one as well. On this side, let me check that one. Yes, so this is the first MOSFET and this is the second MOSFET, I guess. So we can confirm it by checking here. Yeah, you can see a big trace going from this point to here. So this is the first MOSFET, and here we have a diode which we call as TVS diode, transient voltage suppressant diode, which is responsible for bringing down the highest voltage back to ground. So if the adapter receives more than 25 or 30 volts, so it will break down the voltage to ground for the safety purpose. So that is the diode there. Okay, so the main power rail is present, so we have proper switching, which is 19.4 volt, which is pure DC power supply voltage. Okay, so we need to check whether we have LDO voltages. So for that we can check the battery connectors. So always we can check easily from the battery connector to check the LDO voltages in this motherboard. Anywhere in every motherboard we can use the same formula, the same step. Okay, no, there's no voltage, no LDO voltages. Okay, now we need to check the standby IC from now because we don't have the LDO output. So this is the standby IC in this motherboard. So we can see here it's the model number Yeah, it looks like 20EL. So normally Richtech IC is written as 20EL for, so they have written in numbers, so in order to easily code the model number in the chip, so they have converted as number, so 20EL. So we can open the schematics and find the model number and check the signals which is needed for it to release the LDO voltages and also the coil voltages. So normally LDO voltages, we need a enable LDO signal to the to the standby IC, and also enable coil voltages of the 5 volt and 3 volt for the standby IC. So we need two signals for this to turn on. Some of the standby ICs would not require for enable LDO voltages. Once the main voltages as 19 volt is supplied for the standby IC, it will automatically generate the LDO voltages. So let's see what this IC is doing in this section. Okay, now let's go for the schematics. So let me try to identify the schematic. So this, the model number is DA0R33MB6F1. So whenever the model number, the part number starts with DA, so the production is from the Quanta manufacturer. Okay. Okay, we managed to get a schematics of this motherboard, and this is the standby IC in this motherboard. And if you look here, the model number is different actually. So it's UP1585QQAG. But on the motherboard we saw it was a Richtech IC. It is a Richtech IC. So actually I think this chip and also the chip on the motherboard is also interchangeable. So they are equivalent. So that's why they have mentioned as a different number in this one, but on the motherboard is a different IC. So anyway, let's find the model number of the Richtech IC on this motherboard. Okay, so we identified the datasheet of this standby IC. So this is RT8223P. So we can identify on the marking on the chip. So always RT8223P will be marked as 20, and the year and the date of the manufacturer will be on the next side. So whichever IC of the Richtech starts with 20 equals, which means that is the Richtech IC with the model number of 8223P. So we need to check the signals that is most important for it to release the LDO voltages and also the standby current, full current voltage. Okay, so we can move on to the schematics. So on this schematics, so this IC has different enable signals. If you look here, the enable and tripper of pin 1, so they have grounded it, and also enable and tripper pin of the channel 2 is also grounded. But they have used one pin which is on pin number 18 to enable both channels, which is enable the chip, just a single pin which will enable the both channels. So if you see in some other schematics, so they will not connect this one. Pin number 18 will be left floating, and they will use pin number 1 and pin number 6 separately in order to turn on these channels. So but on this schematics, you can see they have left the enable and tripper pins on this one as left open, and they have used pin number 18 as the enable signal for this chip. So we need to check on pin number 18 whether we have 3.3 volt in order to release the coil voltages. And let's check on pin number 13. So pin number 13 is directly connected to the V-in line, which is the 19 volt. So it will automatically turn on the output voltages for the regulator, the LDO voltages. So if you look here, they have mentioned as star beside the resistor. So normally Quanta manufacturers usually use star for no stuffs on the motherboard. So as well as this one here, so they have used the star at this point. So in this section there is no need a voltage at pin number 13, so automatically it will turn on once the V-in line voltage is supplied to the standby IC at pin number 16. But actually at this time we need to check PR116. So if the resistance value of this resistor increases from 10 ohms, then we will not get a voltage of the LDO voltages, both of the LDO voltages, even the coil voltages also we will not get. So we need to find that. Okay, so we can check first on pin number 16 whether we have 19 volt. We can check the PR116 whether the resistance value is accurate, and also we need to check, we can also check on pin number 13 whether we have any voltages. Actually we will have a voltage on this point, like from 1.7 or 2.3, something like that, but it should not be always, it should not be low logic, which means it should not be ground. We should have a high logic on pin number 13 in order for the entire standby IC to start its function. In some of the motherboards you may have noticed that enable 0 will be connected to the thermal protection circuit in the motherboard. So once the thermal protection motherboard protection circuit in the motherboard is activated, it will directly pull this 13 pin to 0. Then the standby IC will shut down and the entire motherboard will fall down and they won't work. So that's the protection circuit. So in this motherboard they have not used that, so we'll just leave it as alone. So for the sake, we can check whether we have a voltage on the pin number 13. So the other voltage is that we have to check on pin number 18, that is on the SIO on signal that comes from the EC chip. So pin number 30, if you go there, so there will be an EC chip, so that will send SIO on signal. So we need to check both of the voltages whether we are getting. Okay, so this is PR94. We can check on PR94, and I just wanted to tell you something. So whenever you have some components near the ICs, so try to measure on the ICs, or like if you want to measure, for example, the enable and tripper voltages, just try to measure on this resistor. Do not touch this one, the pin near the pin on the chip, because sometimes you might short other pins and it will cause it will damage the chip. So that's the thing. So in this case it is okay, but if you see some of the standby ICs or some of the ICs, there will be V in supply pin next to the enable signal, so next to like the LDO voltages. So if you short the LDO voltage with the V in voltage, what will happen? So it will short the entire chip. Sometimes it may cause even more short to other components in the motherboard. So be careful on checking these things, and also always use the needle probe so you can measure very tiny components without shorting other components. Okay, so now let's check on the motherboard whether we have all these voltages. Okay, now let me connect the adapter. Okay, now the adapter is connected. Right. So we need to check first on the current sense resistor here. So on pin number 16, we have the supply voltage for the standby IC. So let's check that. So this is pin number 12, 13, 14, 15, 16. Wait a second. 6, 12, 13, 14, 15, 16. So this is the supply for the chip. Okay, let's check here. And where's the 10 ohm resistor? Wait a second. So here we have a 10 ohm resistor. Yeah, it's written as 10 100. So 10 to the power 0 is 1. So it's 10 ohms. Okay. Yeah, we can see the trace is going from this point to this point here. so it's clear. So this is the 10 ohm resistor for the chip. So we need to check the voltage on this side and as well as on this side, so the voltage should be same. Yes, 19.4 volt, 19.4 volt. Okay, so the voltage is going into the chip. Anyway, I'll just check the resistance value also. So always try to disconnect the adapter for checking this time. Yeah, it shows us 32 ohms. Okay, so 32 ohms is way too high, 3 times higher than the actual value. So it should be 10 ohms. So this resistor has increased its resistance. So basically this resistor won't increase its resistance normally in a normal condition. So if there is any problem on this chip, so if this shorted, so this resistor will increase its resistance. Okay, so first I will change this resistor and check what happens here. Okay, before that I'll just check the ohms value on the output side of the resistor just to confirm it with regard to ground. 0 ohms. No, we are reading, yeah, kilo ohms, 43 kilo ohms. Okay, that is fine. So I guess there's only a problem only with this resistor. So as the resistance value of this resistor increased to 32 ohms, the current supplied to the standby IC was not enough. So that's why it's not releasing the LDO voltages and also the coil voltages. But normally, even though the resistance value is increased to 3 times than the usual value, so the standby IC should release the LDO voltages, because LDO voltages are having a low current on that voltages. So therefore, it does not require more power to release those voltages. But in order to release the coil voltages, it needs more current on the input side. So then only they can release the coil voltages. So anyway, I'll just replace the resistor and see whether we are improving with the voltage output. I'll just cover this connector with this one so that it don't melt it when heating up. Okay, right. I have searched everywhere with my spare parts and motherboard, so I don't have 10 ohm resistor, but I have a 0 ohm resistor. So this can act like a fuse. So whenever there's a short on the chip, so this resistor will increase its resistance. So there's no problem. So I'll just keep this on this place so we can fix it here. Okay. Fine. Now let me check whether the resistance value is appropriate. So this resistor should have 0 ohms. Yes, this is 0 ohms. Okay. Fine. Let me connect the adapter now. No. Still there is no current reading. So what about this resistor? Did it increase its value? So if this resistor increases its value again as the previous one, so there's a problem with the standby IC. So we need to check that one. Anyway, I'll check the voltage first. 19 volt. Yes, 19 volt. Okay. Let me check the resistance value. Yeah, 0 ohms. So now we need to check whether we have the LDO voltages. Okay, let me connect it again. So LDO capacitors, I think this one here. So we can check on the output capacitors. No voltage. No voltage. So only these are the capacitors here. So I think on pin number 8 we have the LDO output 3.3 volt. Okay, so on pin number 8 is where? So here we have the 6, 7 and 8. Yeah, so this capacitor is responsible for filtering the 3.3 volt LDO voltages. So I think there's a problem with the standby IC as well. I think we need to replace a brand new one there. Okay. So you see how does the fault comes into the motherboard. So when this standby IC gets shorted, so this resistor has increased its resistance from 10 ohms to 32 ohms. So whenever you see increased value in these types of resistor, which gives the voltage into the chip, so you should understand that there's something happen into the chip here. So that's why the value of this resistance increased. Okay, now I have another brand new chip with me, the standby IC, so I'll just replace it and check whether we have the LDO voltages. Okay, everything is okay, I think. Yeah, so let me clean it. Yeah, that's fine. The pins are soldered properly. Okay. Okay, so let me check this time whether we have the voltages, the LDO 3 volt and 5 volt. I'll just connect the adapters. You look at the ampere reading. Yes, it's went to 35 milliamps. Yes, the light is glowing continuously. You can see the light is glowing continuously. So now we have solved this problem. So right now the EC chip is working fine. So it is sending, so this EC chip is sending that AC detect signal after receiving from the from the charger IC to notify that the adapter is connected. So let us check whether we have a voltage on the standby IC. The LDO output capacitor is here. Yes, 3.3 volt. On the 5 volt. Here, yes, we have a 5 volt. Okay. Now let's check whether we have 5 volt and 3 volt coil voltages. Okay. No, but we don't have a 5 volt and 3 volt coil voltages. So in this motherboard, normally we should get a 5 volt and 3 volt coil output before pressing the power button. So EC chip is responsible for giving the S5 on signal to the standby IC here, so that the standby IC will release the 5 volt and 3 volt coil output. So we are not getting the 5 volt and 3 volt. So let me press the power button to see if there's any reactions. If you notice the ampere reading, when I press the power button, it is increasing to 29 milliamps, then back to 9 milliamps, but there is no reactions. So the board is not turning on. Okay, now we have to move to check the SIO in this motherboard, the EC chip here. So such as we need to check the RSM reset signal and also EC reset signal and power button output signal. And also here we have the BIOS of the EC chip, which is outside here. So in today's motherboard, in the modern motherboard, we can see this chip is inbuilt inside this EC chip. So in earlier motherboards, it is outside, so it will be easy for us to reprogram it using a simple USB program as well, or even an advanced one. So we need to check whether this BIOS is okay. So for that, we need to use the oscilloscope to check on the pin number 1, which is the chip select pin. So if there's any reading on the chip select pin, we can confirm that the EC chip is communicating with its BIOS here. Okay, so first start from the EC reset signal and then to RSM reset signal. And also we need to find whether we have the S5 on signal going from this chip to the standby IC. Okay. Yes, so first we can check the EC reset signal that is on pin number 37. Okay, we can check the EC reset signal. So it should be 3.3 volt before pressing the power button. So once we connect the adapter and once we get a 3.3 volt LDO output, we should have the EC reset on the pin number 37. Okay, let me check that. On pin number 37. So this is so here we have 32, 33, 34, 35, 36, 37. So we can check on this point here. So it should be 3.3 volt. So we have a 3.3 volt. So here you can see, yes, 3.3 volt EC reset is okay. So that is fine. So the next signal should be the SI on and also the RSM reset. The RSM reset is on pin number 95. So we can check that as well. So sometimes the RSM reset is high when before pressing the power button. Sometimes the RSM reset will be high after pressing the power button depending on the motherboard. So it can vary depending on the motherboard. So let's check on pin number 95. 95 is on this side here. We don't have a voltage there. Let me try to press the power button. Yes, did you look at this one? If you notice that I am pressing the power button and look at the ampere reading, it is increasing. At the time the ampere is increasing, we are getting the high logic for the the RSM reset. But the RSM reset, it is not staying still. So it is going to low logic immediately within 1 second or before 1 second. Okay. So the EC chip is working fine on some condition. And also if you have a high logic output on the RSM reset, the BIOS chip is also okay and the BIOS inside this is also okay. But anyways, to cross check whether it is okay, we can check with the oscilloscope. Okay, let me see with the oscilloscope whether the BIOS is okay. Okay, so now you can see the display of the oscilloscope in the screen. Now I am going to test the BIOS chip once I plug in the adapter. So let's check together. Okay, now I am going to connect the adapter. Look at the oscilloscope. We should have a reading. Yes, you see those bars represents that the EC chip is pulling the pin number 1 of the chip select low in order to read the BIOS inside this. At that time the EC will capture or record all the BIOS from this chip and it will retry to this chip here, to the EC chip, and it will start to function, and the pins on each of the EC chip will be configured only after reading the BIOS inside this BIOS chip. So let us check again. You see there's a reading. Okay, and after some time it will stop, because after some time all the BIOS will be read. So there's no problem with that as well. So the BIOS is reading fine. Yes. And also we can also confirm that the adapter light is turned on by the EC chip. If the BIOS region of the EC chip is not okay, then this light won't be activated by the EC chip. So we can confirm this also, that from this also that the EC chip BIOS is okay. So we can check what else we can check here. Okay, there's another signal which we have to check, that SI on signal, whether it is releasing from the EC chip to the standby IC. Okay, and SY on is on pin number 101. Okay, we need to check on pin number 101 whether we have a voltage. Okay, so pin number 101 is on this side, 97, 98, 99, 100, 101. So this is the 101 after this ball here. So this is 101. So we can check that one. So we don't have any voltage. I'm probing on the point, so we don't have any voltage there. No voltage. Okay. So I can check from the standby IC as well whether we are receiving the voltage. So on pin number 18, so we are receiving on pin number 18 the SY on signal. So let me check that. Wait a second. So here we have a solder board. We need to remove that so it is connected together. This should not be like this. Actually, I didn't see this. Anyway, we are safe from that. Nothing happened. So if you are careless or if you didn't see these types of things, so it might short the components. You must be careful. Okay. Okay, so the pin number 18 is on this side here. So on this side here we have 19, and on this pin on the edge side, so this is 18, and you can clearly see that the trace is going from through this way to this resistor. So most probably this is the SY on signal comes to this resistor and goes out of this resistor and get filtered in this capacitor and goes into this standby IC. So we can check the voltage there. Now I am connecting the adapter. Okay, yes, my multimeter. Okay, no voltage there. Okay, there's no voltage. So let me see whether we have any low impedance on that. So on the input side of the resistor, no, we don't have much low impedance. So 1.6 kilo ohms, so that is fine. On the input side, yes, 1.6 kilo ohms. So the EC chip is not sending the SY on signal to the standby IC. So what can we do now? So we need to find an alternative voltage just to give a voltage on this pin here on this resistor. Okay, so now we are having 1.7 kilo ohms on this side, and also there is 1.7 kilo ohm on the output side as well. So EC chip should send the signal in order for the 3 volt coil output and also the 5 volt coil output to be generated, but it is not sending the signal. But there's another important thing, it is also not sending ground at this point. So it is a good point that it is not sending a ground, but it is just leaving this as an open drain. So but it is not sending the 3.3 volt at this point. So always we don't need a voltage at this point from a particular area, but if we just give a voltage like 3.3 volt in this point, to this resistor, the standby IC will recognize that it was asked to regulate this 5 volt and 3 volt output. So in consideration to this thing, so it will output the 5 volt and 3 volt. So what I'm going to do now, I'm going to isolate this area from the EC chip. So I'm going to remove this resistor. I'm going to remove this resistor so that this point and this point will be isolated from the EC chip. So anyhow, we need a voltage at this point in order to get the 3.3 volt and 5 volt output. So already we have a regulated 3.3 volt LDO voltage from this same regulator. I'm going to connect from this point to here at this point. So while I'm connecting this, once the LDO voltage is generated, at the same time the coil voltage of 5 volt and 3 volt will be generated, because at the pin number 18, once the LDO voltage is generated, pin number 18 also will be 3.3 volt. So that both the LDO voltages and the coil voltages will be enabled at the same time. So the actual problem is with the EC chip. So the EC chip is not sending this S5 on once it receives the power supply as 3.3 volt to the EC chip. So for only this reason, we may not change the EC chip, that it is not sending the S5 signal. So EC chip is a highly costly one than these regulators. So to make it as cost effective, what we can do, we can just bypass those signals like this one here. So only the EC chip is not functioning, or it's not giving a good signal on S5 on. Other than that, all other compartments are working fine. Okay, we'll just confirm it. So we will just try to see. Okay, so now I have already tested by jumpering the 3 volt LDO from the S5 enable signal here, and the board is working fine, and there's no problem with the EC chip here. The only problem with the EC chip, it is not sending the S5 signal to the standby IC. Other than that, the EC chip is working fine. For only this problem, we no need to change the EC chip, so we can just bypass it. So it will be a cost effective way. So I'll just show you everything. So I'll just connect the adapter. Okay, so the display of the power supply is visible to you now. I'm going to connect the adapter now. Yes, it's taking around 10 milliamps. Okay, and we can check the 3 volt and 5 volt LDO voltages, and also the coil voltage of their 5 volt and 3 volt. Okay, so we have 3 volt and here we have 5 volt. Okay, so the LDO voltage also is present. Now I will try to trigger the power button, so you can see the board will turn on. See, the board is turning on. So the problem is with the standby IC. So we have replaced a brand new standby IC, and also the S5 signal from the EC chip is not released once it receives the power. So this is a problem with this EC chip. So currently the ampere is taking around 1 ampere and 200 milliamps. So let me connect the keyboard, or else I'll connect the mouse so that we can see whether the display is executed. Yes, the display is executed. You see the light on the laser light on the mouse is glowing. So there's no problem with that. So thank you so much for watching. So we have prepared another motherboard, and stay tuned, we will give you more informative videos in the future, and bye for now.